Hi, I'm an electrical engineer at the University of Utah, and today we will learn how to produce sine waves using oscilloscope and a function generator. The second part of the experiment will consist of how we can produce different waveforms using a microphone. First thing we need to do is to connect the function generator with an oscilloscope. What we have is a probe with two ends. The first end goes to the function generator. The second end goes to the oscilloscope. You will notice that the oscilloscope has A1 and A2 as two ports. You can use either of those two ports to connect. Once we have connected the probe with the oscilloscope and the function generator, now we are ready to turn the equipment on. Proper setup of the probe between the oscilloscope and the function generator will produce a sine wave as seen here. Notice the frequency flashing on the function generator. It is set to 1 kHz by default. We can increase or decrease the frequency by using the dial. If we increase the frequency, we see that the number of cycles decreases. If we decrease the frequency, we see the number of cycles increases. Let's try 5 kHz frequency. Notice the number of cycles on the oscilloscope have decreased by increasing the frequency. Now, if you decrease the frequency to less than 1 kHz, the number of cycles on the oscilloscope will increase. I've set the frequency to 900 Hz on the function generator, and you can observe the number of cycles have increased on the oscilloscope. Now we will learn how we can produce different waveforms using a microphone. First thing we need to do is to connect the microphone with the oscilloscope. Remember, sound waves are dependent on three major properties: wavelength, frequency, and the pitch. For example, if I talk gently in the microphone, it will produce small amplitudes. If I talk in a more louder tone, it will produce bigger amplitudes or larger amplitudes. Let's try that. Hello! As you noticed, I talked in a louder tone and it produced a higher amplitudes. Now I'll talk gently and it will produce small amplitudes. Hello! If we want to see the waveform produced in a much more distinct fashion, we can use the run-stop function in the oscilloscope. We can also try different other noises to see variation of waveforms in the oscilloscope.